Hello everyone, myself Yash Kumbar, and very welcome to you on a very important topic and also interesting topic, that is Verilog. Today we are going to discuss on Verilog and we are going to see a simple example on it. Understanding Verilog for beginners. For introduction, Verilog is a hardware description language used to model and design the digital circuits. It contains modules, data types to describe the hardware components and controls the structures to model the behavior of the hardware. We are going to see modules, what is modules, data types, and how it describes the hardware components in the further slides. So let's move towards the main presentation. What is Verilog? Verilog is a hardware description language. It's simulation and synthesis of digital circuits. It simulates the actual behavior of the logic gates and synthesizes the circuits to fit into the actual hardware. Whereas I whereas we can design a circuit through this simulation, Verilog. The evolution of the Verilog is over the years, with the latest version being System Verilog. It has enhanced the construction of verifications, assertion, and the test benches. We now recently uh, we can verify the circuits on Verilog. The basic syntax of the Verilogs. The basic syntax of the Verilog starts from the modules. A module is a basic building block in Verilog. It describes a digital circuit and has input and output ports. It can be instantiated multiple times. Yeah, there are many other options for it, but the second one is comments. Comments, Verilog supports the single line and also the multiple line comments, which are very useful to us to understand or to get actual what it is, very in a simple way we can say it. Next, the third is the operators. Verilog has a variety of mathematical operators to manipulate binary values. Logical, bitwise and arithmetic operators are supported. There are many other syntaxes we will discuss further. These are some loops which are used in our basic codes. If else, for loop, case. The case structure is used to evaluate a value for the set of possible values and execute the statement in the matching cases. Let's move towards the example. A very simple example. We have taken here two input and gate for our understanding. First, the keyword module and the and underscore get is the name of the module. Whereas we have taken, let me show you the inputs which we have taken. Here, the module is a keyword and underscore get is the name of our module. Here we have taken two inputs which names are A and B, and we have declared that output of our two inputs will be Y, and the statement for and will be assign Y equal to and A symbol and B, and we here end the module which we have started here. That's all. This simple is our code. Let's go to the deep in the code. Module defines the keyword module defines a new module or circuit with the name and underscore gate. This is like the main function in the other languages. The keyword input declares the inputs to the circuit. Here, A and B are two binary inputs, as I have mentioned before. The keyword output declares that output from circuits. Y is the output in our code. See, Y is our output in our code. Assign statement, keyword assign statement defines the logic where we have assigning the value Y to A and B. It Y gets the value of logical and of inputs A and B. The keyword and is the logic and operator in Verilog. As you all know, and is a logical operator in all languages. So if both A and B are 1, Y will be 1, else 0. This is the base, this is the truth table we will see further. The end module, the keyword end module marks the end of the module definition. See, here we can say we have started from module and the name of the module, and here we end the module as we do in HDL. So, in simple terms, the code describes a two input AND gate circuit with the inputs A and B, output Y, and Y will be one only if the both A and B are one. Implementing truth table of and operation. I kept the circuit simple, but we can develop more complex, combinational and sequential, like adders, multiplexers, etc. by using these basic Verilog concepts of modules, ports, continuous assignments, etc. The conclusion and the key points of our today's lecture was: a module in Verilog is the basic building block that describes a digital circuit and has input and output ports. For this, Verilog, other people say Verilog is a very difficult language, but it's not like that, students. So we here we can declare that you how much practice you do, the practice you do, the way you will get very simple or very hand free on the Verilog. Verilog is a very easy language to understand. Today we have seen some basic points. In our next lecture we will see some more interesting circuits. We will design more some interesting circuits like half adder, full adder, and etc. So that's all for today's lecture. Thank you. Let's meet for the next lecture. Thank you.